All right, so I've opened up the project as we've left it. Right now, if I compile this should compile because we left it in a good state. And we're going to convert this code, hopefully, to be able to use the ESP32 board instead of the Maduino board. And I anticipate there's going to be a lot of these classes that we created that are going to have issues because they're just not compatible with the new board. So we're going to go on that adventure together and set about refactoring all these classes so that they work with the new ESP32 board. So first things first, I've already set up a Git branch. So if you look here, I'm going to show the list of branches. And I have a new ESP32-S3 branch and that I'm currently checked out. And the first thing I'm going to do is in platform IO, this is the dependency of the old board. And I don't want to delete this. There is a tag up here that says that's the environment for the 0 USB, which is the Maduino board. I just want to add our new environment. So if I go back to our sample that we covered the last time, I can insert this new environment, and this is for the ESP32-S3 board. And I got this from the example that we covered last time. If you haven't seen that example, I'll try to put a link up in the corner there. So now that we have this new environment, if we go to the bottom, there should be two environments now. And I can see it's pulling in stuff that it needs for the new environment. But now I should be able to select this environment. And now when I compile, it'll compile against this new board. And when I compile this, I'm expecting a lot of red. So a lot of failures here. And we're just gonna, again, this is the adventure that we're going on over the next couple of videos. So that, again, is to be expected. What I'm gonna do is I'm gonna go to our main CPP file. And I am going to comment out everything that we should not need. So now I've got all the loop commented out and I've got all the setup commented out. I'm going back to the example that they provided for the file, and I'm just going to drop in what would look like the minimum that we want. So I'm just going to set up the serial port. I'm going to add a comment here. So that's our starting main CPP file. I'm not expecting this to compile. I think this particular file will compile, but I think we have other files that are over here that are going to give us some issues. All right, so here it's complaining that there's an Arduino low power. If we go back to our dependencies, maybe we're just going to right away drop in these same dependencies just to see if we can get it to compile. So here's some architecture that's not supported. So this particular library that we pulled in for the SD card, it's throwing an exception, a compile time exception, saying that that particular board isn't supported. So we have that to figure out. And then we see a number of these things. So we've used this serial USB object to print strings to our console. And that serial USB object isn't defined on every board. It's named something different. And in fact, we saw when we dropped it into the main CPP class that for this ESP32 board, it's just called serial. And so we're going to have to look and see how to abstract that away so that we're not using these board-specific names, that we are using some abstraction around that. So we'll try to solve that problem. And then down here, it looks like there's another issue with the low power library. So again, some of these libs that we pulled in, they may not be compatible with this ESP32 board, so we'll have to work on that. Here's another constant that was defined someplace. This AR default was defined in the Maduino, but not in the ESP32. Again, here's another function, analog reference, which was in the Maduino board, but not on the ESP32 board. Another piece of code here in the battery class is this constant A1, which is not declared for this board. So that's our challenge, is we're gonna work on abstracting away these things and making this thing compile in the ESP32 board. The end goal with this is to have a set of code where I can swap boards in and out. So the first bit of refactoring we're going to take care of is we're going to abstract away the board specific implementations for how you write to the console. You know, the naming, for example, was serial USB for the Maduino board, and the implementation was named serial in the ESP32 board. We use a limited number of features for each of those implementations, and luckily for us, the features we use have the same syntax, so we can easily write an abstraction around these implementations. And I've done that already here. It's called console. And so I have a console.h and the implementation file. We'll look at that in a second. And you can see at the very top, I'm conditionally adding a constructor that takes an instance of each board's implementation for this class. And then you can see a common set of methods that are available for each of the implementations. And down below, you can see I'm conditionally adding a private member that stores the parameter that was passed into the constructor. And if we look at the implementation of this class, you can see at the very top, there's board-specific implementation of each constructor. Again, taking the board-specific serial implementation, and I'm storing that as that private member. And then you can see down below that all of these individual methods defer to the implementation of the board-specific class. And the only bit of trickery is there's a pound define that sets which type of board we're using. And that is going to be set up in the config file. So if I look in the config.h file, at the very top, right now I have two different board types. I have the Maduino, and then I have the ESP32 board. And I've already taken this console implementation, and I've started to push it into the various files. And at the very top of the main CPP file, you can see I'm instantiating an instance of our abstraction. And depending on which board type it is, I'm feeding in the correct parameter. But then after we have instantiated the abstraction, you can see that all the rest of the files are using that abstraction. And even when I want to print something in the main CPP file, I'm using the abstraction to print that file. And if we dig into one of these, for example, let's dig into the AT command class. We can see the constructor takes an instance of our abstraction. And then we can see that everywhere that we were using the board specific implementation, we're now using our abstraction. And just a little bit of foreshadowing, you can see here some code with a board specific implementation of the serial connection between the board and the SIM7600 module. I foresee that we're going to have to do a very similar refactoring and abstract away that implementation also. We can take a look at one more area where we are using this abstraction is the hardware class. And now the hardware class now takes an instance of the console abstraction, and then everywhere where it was using an instance of the board specific implementation, it's now using the abstraction that we've created. And as a good habit, I mean, as we refactor, we'll do incremental refactoring and incrementally make sure that we're building. And so after this pass of refactoring, let's make sure that our code builds. And so now we'll deploy this version of this code to the board. And we'll look at the console output here. And so we hit this kind of a little bit midstream, but it's already kind of in our main loop, our main CPP loop. So now if I restarted the board, we should now see kind of all of the console outs. So we can see that everything's functioning as we wanted. We're getting all of the data that we normally would see in the stream back to the board. This refactoring is a success. Console out is still functioning, but we're not using the board specific versions of the print lines, and we're actually using our abstraction. All right, let's cover our next little bits of refactoring that we've done here. In the sleep class, I now have conditionally included the Arduino low power library. And if you look in the platform IO, this library is part of the Maduino board, but it's not part of the ESP32 board. The ESP32 board has a whole different architecture for sleep, and We'll get into that in probably a different video. But for now, I've removed the Arduino low power library. I've also removed the Arduino SD card library. But if we go back to the sleep method, so here I'm conditionally now including that Arduino low power library only if we got the Maduino board. So there was a change to the constructor now. I've added an instance of the abstract console because we do use the serial here, and I'm keeping an instance of the console down below. In the implementation, we actually see the constructor. The only change here was the abstract instance of the console is passed in as a parameter. And if we scroll down, there are a few members that were private methods. So the MCU sleep method and the MCU deep sleep method, I'm conditionally adding in calls to the low power library if it's there. And then I've put some conditional statements in here for future investigation. So we'll investigate the ESP32 sleep and deep sleep options, and we'll add those in here later on. But for now, I've just kind of stubbed that in. And then down below, you can see I've swapped out direct calls to the serial USB, which is the Maduino specific implementation, with our abstract class. So let's look at the battery class here. There was a dangling include statement here that wasn't necessary. I just removed that. We don't need that in this class. And then nothing else actually changed in the header file. In the implementation, if we go from the top, you can see that I've commented out this line. This line, the analog reference, is a Maduino specific call. In particular, this AR_default was only defined in the Maduino. But because it's using the default setting, I don't think it's necessary to even call this function. So I've just got it commented out here as a reminder that, hey, if there's some problems later on, we start to troubleshoot the Arduino or the new ESP32 board, I can look back at that. And then this line of code only changes, there's an extra space in there now, or before I removed a space. So we scroll down a little bit in the private methods. Now here is where you can see I'm conditionally setting the pin value. So previously with the Maduino board, there was a voltage divider set up on pin A1. With this ESP32 board, I took a brief look at the schematics. It looks like I'm on pin 3, but I have not tested this yet. So I've just kind of put that in there as a placeholder, and we'll test this later on. I want to get this to compile. And then down here at the bottom, I don't think I changed anything. These are probably just space differences. So here you can see the different spaces when the code got reformatted, and that's it for the changes to the battery CPP file. So with those small changes now, I'm in the Maduino environment, and I've got my config file set up for the Maduino board. I should be able to compile this, and I've successfully compiled. I should be able to push this over to the board, and I do have this board hooked up to the USB right now, and so it should be able to successfully push it over. And if I look at serial monitor, then I'm getting code out. So it is looking like I'm getting code out, and so now I'm starting to get GPS points and all of that. So the board continues to function after those small refactors that we've just done. So we switch over to the ESP32 environment, and let's try to build it there. And it does build. I did hook up the ESP32 board. I don't really anticipate that even if I can push the code over to the board that it will function, because I think there's still some problems with the code that we'll have to address. But let's just see what this does. So it did look like it pushed it over successfully. And if I look at the serial monitor output, and after waiting for a little bit of time, we do see some output from the ESP32 board. This is a good sign that we're on the right track. And this output is indicating that it's not able to talk to the SIM7600 module, and the SD storage card is not initialized. And we do know that those two things are different on the ESP32 board versus the Maduino board. And so now we need to do some abstractions around those so that we can use this same code for both boards. Let's take a look at the last round of refactoring here to get this to function. I pulled some of the pinouts that we need for the specific boards into our config file. This is where all of the differences for the boards maintained. So for example, the battery pinout. So both boards have a voltage divider that allows you to kind of use the analog to digital converter to read the battery voltage, but they're on different pins. So here's the pin for the Maduino board, and this is the pinout for the T-SimCam board. And so the battery pin for the T-SimCam is on pin 3, and here it's on already a predefined number, which is it's called A1 here for the Maduino board. But you can see the other pinouts too. So for example, there's an LTE flight pin, and there's a LTE power key pin. This is the power pin for the SIM7600 module, and for the Maduino board it's on pin 5. And then for this ESP32 board that we're using, it's a pin 48. And so now, for example, if we go and look at where we initialize, let's say the SD card. So the SD card is initialized in the hardware CPP file, and we can go and find the function here, and this is the function where we initialize the SD card. You know, we do have a pound defined that adds a line that starts up the serial peripheral interface for the ESP32 board using the pinouts that were defined in the config file. I don't think this was needed for the Maduino board because I think the default parameters for this function just worked. And here you can see we're calling begin on the SD card itself with the correct pin. So this is the ESP32 pinout, which is pin 47. But if we were using the Maduino board, it would be the Maduino pinout. Similarly, if we go and look and see where we start up the SIM7600 module, and again, that's going to be here when we initialize the module. Most of this doesn't use the pinouts, but if we scroll to the bottom where we can start to see where we're turning the module on, here's a little bit of code where we're using the pinouts. So depending on which board, you know, we're writing to specific pins. So for the Maduino board, we drug that pin low and then we drug it high. But for the ESP32 board, we did the opposite. So it went high then low. So a little bit of differences here. That's why there's some duplicate code. But beyond that, it just functions because we know the pins. There was a little change to support the sending commands to the SIM7600 module. If we look at the AT command helper, that constructor now takes an instance of hardware serial here. So for both boards, this was a common class that the serial port interface between the board and the SIM7600 module implemented. So that made it really nice for us just to add this as a parameter to our constructor. And then down below, we keep track of that parameter. And so then if you look at the implementation of it, so here is the constructor. And on the constructor, you can see we're just keeping track of a local copy. And then anytime we wanted to interact with the SIM7600 module, we just use our instance of that local copy. Then back in the main CPP file, you can see the differences here. If we have the ESP32 board, so we're creating the command helper by passing in the parameter serial AT, which is an instance of hardware serial. And if we were doing the Maduino board, we do the same thing. We pass in serial 1, which was an instance of hardware serial. And so with those changes, we should have everything we need to compile and push to the board. So I'm in the ESP32 environment. I'm going to build this. Everything builds successfully. I'm going to push it to the board. I have the board plugged in currently. And let's look at the serial monitor for the board. And so it looks like we missed the output during the setup, but you can see that we're running the loops. And so here's the battery voltage using our new pinout. So this is 4.06 volts on that pinout. We're getting GPS data. So the SIM7600 module, we're successfully talking with it and getting GPS data. We're calculating the distance. I have the distance delta set pretty small so that every point will count for us. So it added that point to the cache, and you can see it sent the point to the API. And then we're just repeating that same thing. So if I look at our API endpoint, which we kind of had before, and again, we're using this webhook.site as an API endpoint for testing. And so you can see about every 10 seconds, we're getting a new point sent from the board up to this endpoint. And again, it's sending it through the SIM7600 module, which is a cellular connection. So there's no direct internet connection with my computer here, but it's actually going out and it's getting the GPS point, and then it's using the cellular network to send that data up to here. But you can see we're getting information about the SIM7600 card, we're getting the battery voltage, and everything is coming through. So this is now functioning just like the Maduino board with some small refactors that we've done during this video. So if we scroll down at the very bottom of the main CPP, you're going to see there's one bit of code that I don't really have functioning yet. And right now the sleep is a very naive sleep. It's only going to delay for 5 seconds and then it's going to go grab another point. This code down here, I've just kind of skipped this code for now, because if you remember, and we look at the deep sleep module options, when we put the MCU to deep sleep, we were calling this low power library for the Maduino board. Now the ESP32 board that we're using has a whole different suite of sleep options. And so in the next video, I want to explore what those sleep options are, and let's figure out what the best thing to do here and also up here on this thing. But that's it for this video. If you're interested in more content like this, like and subscribe.